Hello and greetings. In this video, we are going to see what is a version control system and shall understand in detail the most prominent version control system, which is Git. The intention is to get any developer, make him up to speed on version control systems in a relatively short video. Let's get started. So these are the topics which we shall be covering. What is a version control system and specifically what is Git? What are the common commands? This is a non-comprehensive list of commands which is given here. How can you make your job easy using some GUI tools, graphical user interface tools? And here we shall be seeing SourceTree, which makes interacting with Git very easy. And finally, the process of review, how the reviews are done and how we ensure the code sanity is maintained, that is with the help of pull requests. This also we are going to cover. So what is a version control system? So a file where the developer would be working on may have multiple versions. These versions come because multiple developers may be working on a file on a daily basis or on the subsequent days, and this file keeps on getting updated. Now, if somebody has to know which developer worked on what version of the file and what changes were done, that can be done with the help of versioning. If we have the same file and we keep on making the updates on the same file, we don't know the intention, rationale, and the person who had done those changes on that file. So for that reason, the versioning is used. Let's see the definition. Software tool that helps developers and teams track changes to their code, collaborate on projects. So the other thing is collaborate. So it is not one file, it is a multiple file. It's a complete project where multiple developers have to collaborate and maintain a history of revisions. What changes have been done over a period of time. This tool helps us to maintain that history of that revision. So what are the different tools or what are the different version control systems, also known as source code management softwares? Git, Subversion, Bazaar, AWS Code Commit, Bitkeeper, TFS. So these are IBM Rational Clear Case. These are some of the very prominent, CVS also being one of them, which are being used. So what is a repository? Repository is a central store, data store, where everything which a version control system needs is present. What a version control system needs are the files, directories, version history of a project. It serves as a complete record of project's development and tracking every change made by the code base over a period of time. So this is the comprehensive thing which is helping the version control system do what its job is. Okay, and this repository can be local meaning on your computer, or it can be remote on a server or a hosted platform. What is a hosted platform? It is like a Bitbucket, a GitHub. So those are hosted platforms where the server is managed by a cloud hosted platform. The second thing is branches. So what are branches? Branches provide a way to isolate. This is a keyword. We will see what it means. It provides a way to isolate and manage changes to your code, making it easier to work on new features, bug fixes, experimental changes without affecting the main code base. So let's say that we have one code base and multiple developers have to work on the same code base. So what is typically done is, if this is a develop branch, okay, this is the main code base which is here. uh, I have explained branches in one of the other video which I'll link here in the description. But essentially what happens is, if multiple people, multiple developers are working, if they have their own branches to work on, then they are, whatever work they are doing, that is isolated from the work which any other developer is doing. So if developer A is working here and developer B is working here, both their changes are isolated, and once they have done their changes, what they can do is they can merge their changes back to the develop branch. Okay, and if there are any merge conflicts, they can solve them. So we will see all these terms and terminologies which I am using in a bit, but this is what is a branch. Creating branches in Git is lightweight. This is very important to understand why they are lightweight, as they are essentially just pointers to commit. So this means that Git does not copy and paste and keep hundreds of copies of the code. So if you have created 100 branches, it does not mean that Git is going to create and keep 100 copies of the code base for the tracking of different branches. Instead, what it does is it uses some pointers, and these pointers very smartly uh, are able to retain the history of commits and able to maintain the sanity of branches. So that's what is very important, that it's a very lightweight strategy. This encourages a branching workflow, making it easy to experiment with new feature or bug fixes. Now, because this branching is not a very heavy process and it is not a very resource intensive process, it makes it easy for developers to experiment with features or bug fixes. Consider that if the code was copied and pasted every time branch is created, then it would take time, it would take resources, it would take money, thereby making it very difficult and restrictive on the project budget. And that's where branches would be avoided. But Git makes it very smartly, and that's where creating branches is lightweight and developers can create as many branches as they want. Another important concept, distributed version control. So what is a distributed version control? In this case, every developer has a complete copy of entire repository, including the entire history. This allows for offline work, faster branching, and a more distributed and decentralized workflow. So every developer, so there is a remote repository, okay, and every developer who clones this thing in his or her machine has the entire copy of what is there in the distributed or a remote repository. So from remote, it comes to his local. Everything comes, and Git is a distributed version control system. Now, what is SourceTree? So all these concepts which we are doing, this can be done with the help of a CLI, command line interface, or it can be done using a tool. And SourceTree is one of such graphical user interface tool for Git. It completely animates the need of remembering the CLI commands. Alternatives include Smart Git, Tortoise Git, Rabbit VCS, GitHub Desktop, etc. Let's go through the essential flows which are there in Git. The first one being the initialization of a repository, then the cloning of the repository, then the developer activities, what they have to do in their day-to-day development lifecycle, then the pull request, what exactly is a pull request. If you have to temporarily save the changes, you can stash those changes. How can you stash those changes? We'll see. And then finally, we'll see how to do a PR submission so that your code gets reviewed and finally merged into the specific branch. So initializing a new repository with the help of Git init. So what it does is it created a .git directory. It is a hidden directory. It starts with dot, so you can understand that it is a hidden directory. And it also creates an initial branch. It can be called main or a master branch, and commits an empty commit. We shall see it now. Let me open the console and do it. Just one note before we do that is that typically developers don't do a local git init. So they would be using the Git repository which is available on the remote server, and which is created using some Git platforms like GitHub, GitLab, Bitbucket, etc. And if in case they are creating it for the first time also remotely, then they use the UI provided by these tools to create the repository. So we'll do both. We will do a local init, which is typically not done. And the other thing which we'll do is we will use the UI tool and get the repository created remotely, and then we'll get that repository local in our machine. I'll create a new directory. So if I do ls minus a, you will see nothing is there. A is for getting all the files, including the hidden files. Now let me do git init. So it has initialized the empty repository. If I do ls minus a now, I shall be seeing a git folder. I can go inside the .git and see different files. What these files contain is beyond the scope of this tutorial. Now let's create a repository remotely using GitHub. So this would be same in any other tool also. I'm using GitHub because it is available free. And let me start from here. I'll say new for creating a new repository. I'll name it something. Let me say git underscore source tree. And I make it public. I add a README file and I say create repository. Now what has happened here is a repository is being created here with one branch, and the branch is main. So main branch is created and committed. So what we did was we created a local Git repository, and we also uh, created a Git repository in a remote Git platform, which was GitHub in this case. Now let's see what is cloning. Cloning would help you to create a copy of remote repository in your local machine. So it is typically done when starting the project, work from scratch, or when you need a repository in your local system for the first time. So what would clone do? This is very important to note. It will download entire history of remote repository, including all the branches and commits, and it will create a new local Git repository. We had created this repository just now. I'll go here and get the clone URL. So this is the clone URL. I copy this by clicking here. Now in SourceTree, you can say new clone from URL and give the URL. Okay, so let it be created now. So the repository is cloned in my machine, and we can see that there was only one branch which has been downloaded. This is the local and this is the remote. Okay, this is downloaded. Now I'll do a CD to the repository which is cloned locally with the help of source tree. So if I do ls-a, I shall see the readme file, and I shall also see the .git. So if I go to the cd.git, I go inside this, I'll see uh, I do ls, and I see something called as a config file. So various configurations, if I do a cat on that config, I shall be able to see what configurations are there in that file. So these are the various configurations which are there. If I do a cd dot dot and if I run these two commands, okay, so which is I want to have the local username as John Doe and local user email ID as John Doe uh, at gmail.com. So if I do this, now if I see the contents of this file, these two settings should be stored. So you can see this user and email is there. So this is the user and email by which the commits would be done. Before we move any further, let's see GitFlow. So there are different branching strategies which are possible, and like we discussed earlier, branches are created to isolate the code. So if a developer is working on some feature, he or she would like to work on an isolated branch so that he or she is not disrupting other team activities on the project. So GitFlow is a popular Git branching strategy aimed at simplifying the release management, and I have made a complete video on what GitFlow is. I would put a link in the description. So GitFlow involves isolating your work into different Git branches. So let's quickly see, and I would be speaking in a very simplified way because it is explained in detail in my another video. So we have the main branch. Here it is referenced as master, which we already created. From here we create a develop branch. So develop branch is where most of the development would happen. If in case you have to make any development, any developer would be creating a feature branch. So a developer one may create this feature branch and start working here. Another developer may be working on some other feature. They can create a feature branch here and they can start working on it. And once this work is complete, they can merge it into the develop branch again. And from the develop branch, we create something called as a release branch. And this release branch is what is released. It is like releasable software. Once it is released, it is merged back to your master and you to your develop. So now with this philosophy, let's create master, develop, and feature branch in our Git repository. So you can see if I go view all branches, I can create a new branch. Let's say develop, and this is getting created from the main branch. So create new branch, And this is, now we can see that there are two branches, main and develop. And what I can do is, let's say this I have to work on an additional new feature. Then what I'll do is, I will not directly start working on the develop. Instead, what I'll do is, I'll create a feature branch from the develop. So I'll create a new branch, and what I select here is develop, because I'm creating a new branch from the develop. Let's say feature one. This is a feature I want to work on. I create a new branch. Now I come to the source tree and I refresh it. Okay, refresh remote status. So you can see now that there are different branches which are there. We have develop, feature, and main. Okay, and they are here. And like we were discussing earlier, when we do a branch, it just creates a pointer. It does not create a copy of the code. So that pointer is being indicated here. Now what I'll do is, I will check out the feature branch. For checking out the feature branch, I can double click on this. It will say check out. What is the name of the local branch? It should be the same. Whatever is in remote, the same should be there. You can rename it, but it is ideal to have it the same name. And I say check out. So this has been checked out now. Now I can make some changes to this the feature branch. And before I make the changes, let's see the flow, what we are going to do. So we have already seen initialization and cloning. Now we are seeing the developer activities. So developer will make the required code changes in the requisite branch, and then they will do a git add. Git add, what it does is, it will stage those files. They are not yet committed, but they're staged, meaning that they are ready for commit. And then if I do git commit, those files are committed locally till here to here. Everything is happening on your local machine. So once the local commit is done, I can push those changes to the remote repository. So now these changes are available for other developers. They can pull the changes, and then they would be able to see the changes which are made on the remote repository on their local machine also. So let's see this in action now. So this is our initial state where we had a readme file. Let me make some changes in the readme file. I'll use vi. You can use a text editor as well. Okay, and let me create a new html file. Let's say index. So now it is saying uncommitted changes. So these changes which I had done, they are not yet committed. So what I have to do is, if I have to commit it from the local, which means from the CLI, I can do it from CLI also. But because in this video we are discussing the source tree, we will be doing it from here. So we have to select the files which we want to commit. So I will select these. This was not selected. This is the one which was existing where we made some change, and this is the one which we just added. So what we have to do is, we have to do two things: add for adding to the staging, and commit for committing the file. But though both the things can be done together here by selecting. So whatever is being selected is what is being added. So I select both the files and I say commit. Okay, and it is the mail ID which I had configured. You had seen when I was configuring the mail ID. So this is the mail ID which has been chosen here, and I can give a commit message, my first commit. Okay, it is saying, do you really want to add the index.html file to the repo? I say yes. Now it is indicating that you have committed the file and these changes are ready to be pushed. So when we push them, they shall be available on the remote repository. If you see the repository now, these changes are not available. So I will be doing a push now. So local branches feature one, remote branches feature one, and I push it here. So the changes have been pushed. Now let's see it in the GitHub. So I'll go to the code, and in here you can see that feature one had recent changes which were pushed. So here you see only readme file. In develop also you see only readme file, but in the feature one you shall see the change which we made, plus you will see the index file also. So this was what we wrote, my first change, and index one file was what we had created. So these two changes are already available now here. Now let's go to the concept of pull request. Before we go to the pull request, let's see what is a pull. So you have made your changes. If any other developer wants to fetch the latest changes, or you yourself want to fetch the changes which other developers have done, then in that case you can run a git pull and you would be getting the up-to-date changes on your local machine. So that's a pull. Uh, in SourceTree, we have a top icon where you can click and pull the latest changes. So if I click on the pull, this is what it comes, and I can pull the changes like this. Okay, but there are no changes there, so nothing would be pulled. So now let's see a very important concept known as a pull request. So pull request is meant for review and final merging of code to the proper branch. So right now we had put the check-in, or we had done the push of our code to the feature branch. Now let's say from feature branch we want it to be available on the develop branch, so that other developers who are using the develop branch for creating new features, they have that code ready with them. So for that, the recommended practice is to have a pull request. So pull request, what is the typical development flow? A developer creates a feature branch, the developer makes changes there, he she commits those changes and pushes to remote. This we have already seen. Till here we have seen already. Post that, what happens is the developer will be creating the pull request. This pull request would be reviewed, discussed, and it can be either approved, in which case it will be merged to the developer, or it can be rejected also. And this is very important thing to note. The feature branch you have created can subsequently be deleted. This feature branch is a short living branch and it is not needed further on. So we can go ahead and delete this feature branch. Our code is already there in the develop branch now. Okay, and like I said, version history is maintained, so version history would be maintained here as well. So let's see this pull request in action now. So we are here, and it says that compare and pull request. So I would say this, and there is another option also. This I clicked from the code. If I don't see this icon here, I can go directly to the pull requests and I can say new pull request, or I can click here. Anything is good. So I say, and this from feature, I don't want to pull my code to the main, because that's not a correct approach like we had seen in the git flow. So where I want to move my code is to the develop. So I'll create the appropriate mapping here. From feature, I'm moving my code to the develop, and then I say create pull request. I can write my comment, made changes for feature 1. Okay, now this is all based on your organization rule. The rules may mandate that few developers, like 2 developers, should review and accept the changes before you can merge, or it can be direct merging, which is possible. I have not created any rules here, so I basically don't need any approvals. I can directly merge it here. This branch has no conflict with the base branch, and you can merge the pull request. When I do the merging of pull request, the same code base would be available on the develop as well. So I confirm. Now if I go to the code, and if I see here, develop has recent changes pushed less than a minute back. Main still is in the same state. Develop has both the things. It has the readme, it has the index.html. Now let's see it in SourceTree. So what I'll do now is I will refresh. I can go to repository, refresh. So now what we can see here is that initially there was this origin main. From this we had created a feature. Uh, Basically here develop was also, because like I said, it was a pointer. So from the main and develop were same at that point of time. We created a feature branch, and from the feature branch we have merged our code into the develop branch. That's what we are seeing here. So now develop and feature are in one state, whereas main is still in the previous state, which is mandated here. This is the state where the main is. Now let's say that I have to merge my changes from develop to main. Typically, that is not done. You create a release branch, and when you are ready for release, you merge the code to your master and to the develop both. But let's just for a demo of how this graph looks like, I'll do that. So I will create a new pull request. Okay, this time from develop, I'm moving my code to the main. So I create a pull request and I merge the pull request. I confirm it and merge it. Again, if you see the code, you shall be able to see that the main branch also has the same code now. Now, if I refresh this, so now you can see I have refreshed it and we can see that the main is updated here. And why it is saying 3 behind is because in the local, so in the local, we have not been able to pull the changes. So if I pull these changes locally also, I did perform some uh, uh, merge on the remote repository which I have not pulled yet. So that's where it is saying 3 behind. Let me pull this and now I can see that this was the initial commit. From this initial commit I had created a feature branch and this feature branch I moved to the develop and then this from this develop branch I had merged my code to the main. Okay, so that's what this chart also represents. So let's see stash now. So if you have to temporarily save changes, so let's say you are working on a feature, you have done some code changes, but all of a sudden your product owner or your manager comes and says, no, no, stop working on this feature. This has been deprioritized. Instead of this, start working on this feature. Now you want to stash, you want to save those changes somewhere so that when you have to work on that feature again, you can pull those changes and work from those changes. So that is basically the stash. Let's see how it is done in SourceTree. So I'm double clicking the feature one branch to indicate that I wish to this is the branch which I have checked out and I wish to work on the feature one branch. So what I'll do is I will open the index.html and let's say I make some changes here. Okay, so those changes have been done. If I come here now I can see this stash button has been updated. Okay, why it is updated? Because there are uncommitted changes here. So if I stash this, let's say I stash it and I can give a message here. It's optional, so I'm leaving it for now. So I have stashed my changes. Now it is not showing that there are any uncommitted messages. And if I go to stashes, I can see that there are some work in progress on feature. This is by default message which has come. And if you see here now, those uncommitted changes are not coming. I am doing the index, the cat on the index now, and I can see that the file is reverted. It does not have those changes which we had put earlier. They have been stashed. Now let's say I have to bring those changes back. I can go to this and I can right click and say apply stash, or I can say delete. If I double click, it will apply stash. And I say apply stash, and I can say that there is one thing ready for commit. And if I go here again to index, I see the second change has come back. So this is the benefit of stashing the changes, because you can use those changes again when you are ready to use those changes. Finally, these are CLI equivalent of whatever we saw in this specific video. So all those commands and what they mean, you can run these commands as is from your CLI also, the command line also. This is a comprehensive, little more commands are included here. I'll not go in details, but a lot of commands are included. You can read them and go through them. This concludes this video. Thank you very much.